Okay, so today we're going to look at section 5.1, systems of linear equations in two variables and applications. So, solving a system of equations by using the substitution method. Well, first of all, the solution of a system of equations, say two lines, such as 3x minus y equals 10, and x plus 1/4 y equals 1. A solution for this is the point where they intersect. In other words, a point that is going to be on both of these lines. So one thing we could do to test to see if our solutions are correct, say we have the point 2, -4. What we would do is put that point in both of these equations and see if it works out right. Now I have 3 times 2 minus 4 equals 10. Or minus -4 equals 10. 6 plus 4 equals 10, and that is true. Then I have 2 plus 1/4 times -4. Does that equal 1? This is 2. This becomes -1, and that is true. So this is a solution to these two equations. So let's see. We're going to learn two different methods to do this. So the first one is something called the substitution method. So the trick for this is we're going to isolate one of the variables from one of the equations. Substitute the expression found in step 1 into the other equation and solve the resulting equation. Substitute the value found in step 3 into the equation in step 1 to find the value of the remaining variable, then check our ordered pair and write the solution as an ordered pair. So let's look at a system of equations. And we'll start with 3x plus 4y equals 5, and x minus 3y equals 6. So substitution, we need to pick a variable to solve for and an equation to solve for it in. Well, I'm looking at the second one here, and it looks like it'd be easy to solve for x. So let's go ahead, we'll rewrite this over here and solve for x. X equals 3y plus 6. So now we take this value of x here and we put it in for x here. So I have 3 times 3y plus 6 plus 4y equals 5. Don't forget to bring down the 4y. So distribute this 3 here, and I have 9y plus 18 plus 4y equals 5. Combine the like terms, I have 13y, subtract 18 from both sides, and I have -13. So y equals -1. Then I take this value here and plug it in here. So x equals 3 times -1 plus 6, -3 plus 6, 3. So my point is 3, -1. That is my solution, at least what I think is my solution. So then we go to start here. I have 3 times 3 plus 4 times -1, and does this equal 5? Well, this is 9, this is -4, and it works for that one. Then I plug it into this equation. So I have 3 minus 3 times -1, and does that equal 6? Well, this is 3 minus 3 times -1 is plus 3, and that is true. So my answer is correct. Now, there's one thing I'll say about this. All of these problems you can check your answers on. There's no reason not to. You have plenty of testing time to do so. I'm not saying get bogged down into it. Work the problems, finish the test, go back, check your answers. But there's no reason why you should not check your answers. Unfortunately, more often than not, people do not check their answers. So that's the first method. Second method. This is what they call the additive method. We used to call it elimination. Write both equations in standard form, ax plus by equals c. Clear fractions or decimals. Now, you don't have to do that, but nobody likes working with them, so you can always do that. Multiply one or both equations by non-zero constants to create opposite coefficients for one of the variables. Add the equations from step 3 to eliminate one variable, thus elimination method. Solve for the remaining variable, substitute the known value found in step 5 into the original equations to solve for the other variable and check your ordered pair. So let's look at an example here. I have 2x minus 9y equals 1 and 3x equals 17 minus 2. So first of all, I need to look at this and get it in the right form. So this is what 3x equals minus 2, or 17 minus 2y, plus 2y equals 17. So this and this are my equations. Now, if I multiply this entire equation by -3, I get -6x plus 27y equals -3. Okay? If I multiply this one by 2, I get 6x plus 4y equals 34. Now, if I add these two equations up, -6x plus 6x is 0x. 27y plus 4y is 31y, and -3 plus 34 is 31. So y equals 1. Now, if I go back to my original equation, 2x minus 9, plug in y equals 1. 2x minus 9 equals 1. 2x equals 10. X equals 5. So I believe my point is 5, 1. I've checked it in this first one. Let's check it in the second one here. So I have 3 times 5 equals 17 minus 2 times 1. 15 equals 17 minus 2. It works. So this is indeed my answer. So that's solving using the addition method. We can get nastier. So solve using the addition method. I have 2 times x minus 2y equals y plus 14. And I'm going to write the other one over here. You'll see y. 1/2 x plus 7 6y equals -13 over 3. So let's play with this left one first. Distribute. 2x minus 4y equals y plus 14. So I have 2x minus 5y equals 14. So I have a pretty equation now. Here, if I multiply by the least common denominator, which is 6, I get 3x plus 7y equals -26. So now if I take this and multiply it by -3, I get -6x plus 15y equals -42. And I take this and multiply it by 2. 6x plus 14y equals -52. So now I have 0x plus 29y equals -94. If I divide, I don't think that works out pretty. It does not. So y equals negative 94 over 29. Now, here's a question here. That's a pretty nasty number. And putting it in the equation to find out if that's going to work seems a little far gone. So there is another method to this. We can just do it again. Here we eliminated x's. So now let's eliminate y's. So I'm looking at this and this. So if I multiply this one by 7, I get 14x minus 35y equals 84. And here, if I multiply this one by 5, I get 15x plus 35y equals negative 130. So I'd end up with 29x plus 0y equals negative 46. So x equals negative 46 over 29. Again, not pretty. So that would be one that I would check the answers at the end, definitely. Not while I still had more problems to take. Okay, so let's look at another example of this. 3x minus y equals 2, and negative 9x plus 3y equals 4. So what can I do? I can multiply the top one by 3 and get 9x minus 3y equals 6. Leave the bottom one the same. I get 0 plus 0 equals 10, which is never true. This is no solution. And that's because these lines are parallel. Okay, let's look at another one. All right. Then what about this? X equals 5 minus 3y and 2x plus 6y equals 10. Well, let's get this top one in the right form, adding 3y. So I have x plus 3y equals 5, and I have 2x plus 6y equals 10. So if I multiply the top one by negative 2, I have negative 2x minus 6y equals negative 10. 2x plus 6y equals 10. And I get 0 equals 0. That's because these are the same line. These are the same line. So you have infinite solutions. Okay. So next up, we're going to solve applications involving mixtures. Okay. So what do we got going on here? Let's see. We have how many ounces of 20% and 35% acid solution should be mixed to produce 15 ounces of 30% solution. So this is X, this is Y. Okay. So this is 0.2 X, and this is 0.35 Y. And this is equal to 0.15 times 15. So we have two equations here. We have x plus y equals 15, and we have 0.2x plus 0.35y equals, and this is what, 2.25? So I have my two equations. Again, we have one that has decimals in it. I can go ahead and multiply through by 100 here and get 20x plus 35y equals 225. So here I can eliminate the x by multiplying by negative 20. I get negative 20x minus 20y equals negative 300. That's not right. Something's wrong here. Did I mismultiply the 15 times 1.5? I think that's it. 15 times 1.5. Nope, that's not what I want. I want 15 times 0.15. Oh, that's 225. So 15 times 20, that's 300. So let's see, let's look at this again. X plus y equals 15. 20x plus 35y equals 225. So that should be my equations. Okay. How about we do this instead? Let's substitute. See what happens. Let x equal 15 minus y. So this becomes 20 times 15 minus y plus 35y equals, we still get the same thing. Something's going on here. Did I write the information down wrong? Let's look at this. Let's start anew. Something's going on here. Okay, try again. So I have 20-ounce solution, a 20% solution, 35% solution. I'm going to end up with 30% solution. Okay. And I know I have 15 ounces of this. So this is X and Y. That's where my mistake is. So this is 0.2 times X, or let's go this way. 0.20x, 0.35y. This is 0.30 times 15. That was where the mistake was. So my equations are x plus y equals 15 and 0.20x plus 0.35y equals 0.3 times 15 4.5. That's where the error was. Okay. So now we can go through here and do the same thing we did before. Actually, let's go ahead and do that and get 20x plus 35y equals 450. Then I can solve for x. X equals 15 minus y. Then I can plug that in here. 20 times 15 minus y plus 35y equals 450. I can distribute 300 minus 20y plus 35y equals 450. This becomes 15y, 450, not 400. This becomes 150. So y equals 10 ounces, which means that x equals 5 ounces. Okay. All right, now we're going to go back to our boat rides. So, a boat takes 3 hours to go 24 miles upstream against the current. So we have upstream and we have, stop that. We have upstream and downstream. And we have a distance, a rate, and a time. So a boat takes 3 hours to go 24 miles upstream. So 3 hours, 24 miles. It can go downstream with the current, the distance of 48 miles in the same amount of time. So time is 3. So this is the boat speed minus the current, and this is the boat speed plus the current. And the reality is, you could probably solve this intuitively. So what we want to know is what is the boat speed and what is the current rate. So we're going to say set this up as 3 times b minus c equals 24. So b minus c equals 8, or 3 times b plus c equals 48. So b plus c equals 16. So b plus c equals 16. Here's our two equations. The c's cancel. So I have 2b equals 24, b equals 12. If b equals 12, then the current is equal to 4. So 12 miles per hour, 4 miles per hour. Okay. Applying a system of equations in business. The storage company rents units for $120 per month. Company has fixed monthly cost of $2,100 and variable costs and services of $50 per unit. Okay, so the cost for X units is the fixed monthly cost, 2,100 plus $50 per unit. So write a cost function, we just did. Write a revenue function. Revenue is simply 120 times the number of units, right? Determine the number of units that must be rented in a month for the company to break even. Well, I don't know why they put this one in here, because when cost equals revenue, we break even. There's no profit. Or if you remember, profit equals revenue minus cost. So if profit is 0, then when revenue equals cost, we break even. So when does 120 times x equal 2,100 plus 50x? Well, subtract 50x from both sides. 70x equals 2,100. X equals 30 units. Okay. So I want to go back up here to, not that one. Let's go back to this one. What were our original equations? Let's just go ahead and see if I can find them here. Not much space, but I don't need much. So we had 3x minus y equals 2, and 9x plus 3y equals 4. So we can do this in our calculator. Of course, the first thing to do for us to do this in our calculator, add y to both sides, subtract 2. So you get y equals 3x minus 2. Here, subtract, divide by 3. So y equals negative 3x minus 4 divided by 3. So here's the trick. On your calculator, plug in your two equations. So I have 3x minus 2, and I have negative 3x. Make sure you hit the negative and not the minus. Then minus, and just do 4 divided by 3 in parentheses. So write this as negative 3x minus 4 divided by 3. That way you don't have to worry about estimating. Then graph both the functions. Okay, and you should see where they intersect. Now hit second and trace, and go to number 5, intersect, and hit enter. Now you should have your blinking cursor in there. Let's see if I can do a real quick rendition of this. That's not quite right, but close enough. My blinking cursor is here, and it says first curve. So if you hit enter, it should jump to the other curve, which mine did. And say second curve, you hit enter, and you hit enter a third time, and you get the intersection. Did we have an intersection? That one, do I have the wrong equations? No. Yes, I do have the wrong equations. So I get 3x minus y equals 2. Yeah, those are the wrong equations. But I end up with 0.38 and negative 0.06 to 2 decimal places. That wasn't the ones I wanted to use, but they'll work. Let's go back and do another one that comes out even. So we'll go back to this first one here. So I have 3x plus 4y equals 5. Solving for y. Y equals what? 1.25 minus 0.75x. And then we had x minus 3y equals 6. 3y equals x minus 6. Y equals 1/3 x minus 2. So let's try these, because I'm guessing they'll give us much better intersection. So I have y equals 1.25 minus 0.75 times x. And I have 1 divided by 3 times x minus 2. Graph them. And this looks something like this. And this is what I'm looking for. So again, second trace, intersection. We're on the first curve, hit enter, it jumps to the other curve, hit enter again, and hit enter a third time. And there we go. 3, -1. Is that what we got here? Again, I have different equations, but nice and even. That's all that matters. So that's how this works. You can use your calculator to do this. But again, on a test, we're probably wanting to see the work. So you may want to consider that. And that is all for this section. Have a good day, and I will see you next time.